in order for us to understand why integration works, we need to understand the fundamental theorem of calculus 1 and 2. So we've seen all of these. So we are now in a position to tackle this one here. So now this one here is the fundamental theorem of calculus 1. We will look at number 2 at a later date. So this is the fundamental theorem of calculus 1. So let's look at the fundamental theorem of calculus 1. So in this video, I'm just going to explain this one component only. So forget about this d by dx thing, and forget about differentiating this thing. We will leave it for another time. So in this video, we're just going to look at this one component only. Okay, so let me explain this block here. This block here, so imagine you've got a function f of x equals x squared. I want to create a machine or a function where I insert an x. So x, I can slide. So this represents x here. This is x here. So I can slide. Hang on, let me clean this up. So x represents a location along the x-axis. So I can slide. Hang on. I can slide x back and forth. So let's just say x is currently here. So let's just say x is currently the number 5. So that means I put 5 into the machine, which we're trying to invent, and then that will then give me the area from wherever, from A. Let's just say A is 2. So that means I want this area here from 2 to 5. So you have to tell me this area here. Remember, I can slide x back and forth. X could be over here. X could be 6. So in which case, so when I insert the number 6, it must give me the area from wherever, in our case is number 2, to 6. So it must spit out this area here. So to create that machine, you could say, oh, I'm going to create this machine like this. I'm going to integrate it from 2, or from A, it doesn't matter, to x. Remember, x could be anywhere. X is what you put into the machine. X is what you put into the machine, and then you integrate it from 2 to x of the function itself. You see, this here is the wrong way of doing it. Up here would be technically correct. Down here would be wrong. Let me explain why it's wrong. So you could make this argument where, well, just say you're going to integrate the function itself, but the problem lies in these two clashing, because let's just say x is 5. So I want the area from 2 to 5, from 2 to 5. So you would then integrate this, and then you would put 5 into here and so on. But you see, this is not correct because there's a conflict. Because imagine it's 5. Suppose it's 5 where you put 5 into the machine. So this here would be 5 because you're integrating from 2 to 5. But then what does this mean? Shouldn't it be 20, the constant 25? Because our machine is that you put in the value of x, but then we are using this x squared to represent our function. You see, there's a conflict here. To get around this conflict, we would abandon this and just change the name. So hang on, from A to x of t squared. So if we just change the name, everything works fine. There is no conflict. So let's just say this function which we are trying to invent here, we're just going to call it capital F for the time being, is when you integrate it from A to x of the function itself, just change the name. So now there is no conflict. So when you change the name, if you integrate this, so when you integrate it, it would be t cubed over 3 from x, from A to x. So now you can put this into here. There is no conflict because you insert an x here, and your machine is all in terms of t. In our case, it's t squared. Suppose you have, I don't know, let's say this thing here, sine f of x equals sine of x. So you can invent, if you want it from A to x, do it like this. The capital F equals the integral from a to x. Instead of sine x, you would say sine t dt. So now it will give you the area from a to x without conflict. There is no conflict. If you use t, if you simply change a name from x to t, there is no conflict. Everything works perfectly fine. Whereas if you leave it as it is here, there is some sort of conflict, because if you put in the number 5, then this would be the number 5, but then what would this be? Is this a 25? Is it x squared? There's some sort of conflict here. So change the name. That's why we change it from f of x. We're just changing the name from f of x equals f of x to f of t dt. Simply change the name. Everything will work smoothly. So going back to here, we now understand this component. So we need to address what it means to differentiate this new function that we just invented, because by inventing this function, it will help us to understand why integration works. So we need to create this new function of ours just in order to understand why integration works. And this is just a name. We are calling this new machine that we just invented. We're just giving it a name, capital F of x. Okay?